All right, so in this one, we're comparing negative decimals. And that's really important because the rules change just a little bit. We add like an additional step to the front. It says we're going to compare their absolute values. What are absolute values?
Absolute value is the distance from zero, so distance does not matter if it goes to the left, which would be negatives, or to the right, which would be positives. The absolute value will always be positive.
So because they're both negative, we're just going to ignore the negative and go positive. You see? Okay, so let's take that. It says, then to correctly compare to the negative decimals, reverse the direction of the inequality symbol. Because we're ignoring the negative, we're going to kind of take that into consideration at the end. So first thing we notice is, okay, they're both negative. Then we make them into positive numbers. That's what it means to compare their absolute values. And we start our left to right comparison. 2 and 2. We're good. 3 and 3. Okay, so they're the same still. And then we get to 6 and 7. And this is where they became different. Okay, 6 and 7. All right, so this one's larger. This one's smaller. So you know that the little crocodile has to open, the mouth opens towards the larger number, towards the 7. So you're practically done. But, since we took away the negative, now we must reverse it back. We have to bring it back and say, well, it's not true, because if we looked at a number line, the 2.37 would be a little bit farther if we're talking about negatives. This would be 3 and this would be negative 2. 2.37 would be here and 2.36 would be here, right? Since we're negative, we have to go ahead and reverse our sign and bring back our negatives. In summary, it works the same. We're going to look for the numbers till they're the same, and then it becomes different. We pick which one's larger, then we bring back our negative and flip the sign. Let's take a look. Let's graph negative 1.2, negative 1.2, this would be 0.5, so this is 0.2, and 0.8. Let's graph 0.8, so this would be 5.5, so 0.8 is somewhere around here. We should be able to compare these numbers. Now, I have the number line first in case you wanted to check which one's to the left and which one's to the right. But ultimately, you should be able to follow your rules. So let's take a look at number 8. So first I notice they're both negative. Okay, they're both negative. 0, 0, we're good. Then 1, then 1. And then I get to the 6, and this is where they become different. So this one's larger. Okay. Because this one's larger and this one's smaller, this one would be a little bit closer to the 0 on the number line. Therefore, this one's the larger in this case because they're both negative. The smaller is larger. That's counterproductive, right? Because it's negative. Okay, so there's two ways that you can compare a number. You can graph and see which one's on the left and which one's on the right, or you can look at their place values. You try B, and let's do C together. So I have negative, negative, 0, 0. So with that negative, I'm already thinking backwards, okay? And then I have 1 and 0, they're different already. So this one's larger, and this one's smaller. So I'm thinking backwards. So negative 0.098 is the larger negative value, even though I know I have those words that make it seem like it's backwards.